This lesson explores what it means to solve for a variable, and we'll build this understanding using the idea of balanced equations. To understand balanced equations, we have to understand what an equal sign in between the two sides of an equation really means. Here's an example of an equation, x plus 3 equals 5. What does that equal sign in the middle mean? Well, imagine that I had a balance scale. And on one side, I had a box that contained some mysterious number of marbles. I don't know how many, so I'm going to let the number of marbles in there be x, because it's a number that I don't know the value of. Also on the left side of that balance scale, I have 3 more marbles. And it perfectly balances with the 5 marbles on the other side. So some unknown value of marbles plus 3 equals 5. This one we can tell pretty simply by looking at it, that how many marbles have to be inside the box? It must be 2. So we can see that we've built a physical model that goes with the equation shown at the right. And the equal sign in this case just means that the two sides of the equation balance each other, that they're equal to each other. If we were to take 3 balls away from each side of the equation, it would still balance. Again, think about the physical balance scale. If it was balanced to start with, and I took the same amount away from each side, it would still be balanced. What this looks like in algebraic notation is subtracting 3 from both sides of the equation. So we have the equation x plus 3 equals 5. We subtract 3 from the left, and to keep it balanced, to make the two sides stay equal, we take 3 away from the right. What that leaves behind then, if you look at the physical balance scale, you have nothing but x on one side, and you have 2 marbles on the other, and it balances. So x must equal 2. And we get the same thing when we do the algebra on the right. This says that how many marbles must be in the box is 2 in order to make the equation balance. So here's a more complicated example, and this time I'm going to show you the balance scale first. I have 3 boxes. Each box contains the same number of marbles as the other boxes, so all the boxes are identical. There are 3 mystery boxes plus 2 marbles on one side, and 2 mystery boxes plus 6 marbles on the other. What would an algebraic expression look like that goes with this model? Well, on the left-hand side, we would have 3 x's plus 2. Notice that's 3 mystery boxes plus 2 individual marbles. And we can't add those together. That doesn't give us 5 of anything. These are unlike terms, so we can't add them together. And then on the right, we have 2 x's plus 6 more marbles. In order to solve this, to find out how many marbles must be inside each box, we're going to take a series of steps that keep our equation balanced, that keep the two sides being equal to each other. So the first thing that we might do is to take 2 x's away from the left and 2 x's away from the right. Again, if we take the same amount off of each side, the equation stays balanced. So now we have an equation that looks like this. After we take 2 x's away from the left and 2 x's away from the right, what remains behind on the left-hand side is just 1 x plus 2 marbles, and that balances, that equals 6 marbles. Next, we would take 2 marbles away from each side, and the equation would stay balanced, because whenever we take the same thing away from both sides, it stays balanced. What that looks like in algebra is we take 2 away from each side, and we end up with x equals 4. That tells us that one mystery box perfectly balances with 4 individual marbles. Must be that there are 4 marbles inside that box. X equals 4. It's really important that the steps we take keep our equation balanced, that they keep the two sides of it equal to each other. So here's an example. We have 2 boxes on the left and 8 marbles on the right. In this case, the equation that goes with this is 2x equals 8. Another thing we can do with balance scales is we can just take half of everything on the left and half of everything on the right. That's the same thing as dividing everything on the left by 2 and everything on the right by 2. What that looks like in algebra is 2x over 2 equals 8 over 2. After we take half of the stuff off the left side of our balance scale and half off the right side, we end up with a balance scale that looks like this. It has a single x on the left and 4 marbles on the right. This is the equation x equals 4. So when we divide both sides of the equation by the same number, our equation stays balanced. So here's another example. This equation, this balance, goes with the equation 2x plus 3 equals 5. Step 1 is I want to get the balance so that it has only x's on one side and only numbers on the other. To do this, I'm going to either add or subtract the same thing to both sides. In this case, I see that if I take 3 marbles away from both sides, I'll end up with just x's on the left and just marbles on the right. The algebra for that looks like this. Subtract 3 from both sides and you get 2x equals 2. The second step is to multiply or divide both sides so that there's only one block left. Look at the left-hand side of your balance scale. There's 2 blocks there right now. So I need to cut that in half. That's dividing by 2. If I divide this in half, I end up with x equals 1. And that's the solution to our equation. That's how many marbles must have been in each box to start with in order for our equation to balance. To keep an equation balanced, there are some things you can do. You can add the same thing to both sides. Picture a physical balance scale in your mind. If you add the same thing to both sides, it stays balanced. You can subtract the same thing from both sides. You can multiply both sides by the same thing. Again, picture a physical balance scale in your mind. If you double what's on the left and you double what's on the right, it's still going to balance. Or you can divide both sides by the same thing. It's important to remember that these are the steps that you can take in order to get that variable, that x, that box with an unknown number of marbles, all by itself. The same sequence of steps is going to work when we have an equation with 2 variables and we're trying to get one of them by itself. Most often, the case where you'll have to do this is when you have an equation and you're trying to solve for y. So for example, if I give you the equation 2y plus 6 equals 4x plus 10, and I ask you to get it into slope-intercept form. Remember, slope-intercept form is y equals mx plus b. In slope-intercept form, the y is all by itself on one side of the equation. So what I'm really trying to do is to solve this equation for y. Let's build a model for this equation and then use the steps that we can apply to keep equations balanced to get the y all by itself. So first, let's build 2y plus 6. So on the left-hand side, there's 2 y's plus 6 individual ones, equals, it balances with 4 x's plus 10. So there's a picture of our equation. Now in the next step, what we're going to do is we're going to take this equation and we're going to subtract the same thing from both sides. So I notice that there are 6 marbles on the left and 10 on the right. So I can take 6 away from the left, and to keep it balanced, I have to take 6 away from the right. So now the algebra for my equation looks like this. I have 2y on the left equals 4x plus 4. I got there by subtracting 6 from both sides. The next thing that I need to do is I need to take this equation and I need to cut everything on the left in half. I have 2 y's and I want to find out what only 1 y is equal to. So I'm going to cut the y's in the left on half, and I'm going to cut the x's on the right in half, and I also have to cut those 1's in the right in half. Again, to keep it balanced, I have to cut everything in half. What does the algebra for this step look like? Well, I started with 2x plus 4y equals 4. I divided the 2y on the left by 2. I divided the 4x by 2. And I divided the 4 by 2. When I do that, I end up with y, A single y on the left equals 2x plus 2 on the right. Now I have taken this equation and used the steps to keep an equation balanced to solve for y. I've gotten y all by itself. I still have an equation with a variable in it, x, but I've rearranged the equation so that I can see it in y equals mx plus b form. Again, when we're solving for y, we're applying the same steps that keep an equation balanced to get the y all by itself.